The question you ask is, what happens when it gets out to this thing that says L2? How does it work then? How does it stay there? What is L2? So we're going to do is I'm going to bring up a YouTube video. We're going to watch this YouTube video together. Sorry, everyone, if you didn't want to watch a YouTube video with a scientist today, but that's what's going to happen. So if I bring up the internet again, you can see the video here. And this video is going to show you what L2 is. L2 is a spot in an orbit that is LeGrange Point 2. It's in a spot where if you see the sun here and the Earth, it's a spot that's 1 million miles from the Earth, 4 times as far away from the Earth as the sun, as the moon. And it is a spot where the pull of the sun and the Earth together and its desire to go off in a straight line balance. So it kind of wants to stay there, but it's not going to just sit there. It's actually going to orbit in this fancy circular orbit like this. So this is a pretty good video to show off. It's probably very small for you, and I apologize for that. But you can notice as we zoom in that it's in this fancy orbit where the bottom, the sun shield, is always pointing towards the sun and the Earth. So that means it will always stay hot on one side and allow it to be very cold on the other side. So that's the animation of JWST's orbit right there. And to stay here, to stay in that spot, it actually has to use a little bit of fuel to do something called station keeping, which is where that's not perfectly stable, that orbit. It's a little bit unstable. And so it uses a little bit of fuel every once in a while to kind of keep it there. And when that fuel runs out, JWST floats off into space.
When it floats off into space, then we just lose it, I suppose.
Yeah, here's a simulation. Are you ready for the simulation?
Sure.
Oh no! Sorry, that's a joke. That's my dumb joke. No, we lose it. It goes off into space, and we at that point we can communicate with it, but we can't control at that. Like it'll just float off. And so that is a thing where we're monitoring how much fuel is going to be left over after we park it. And so in the next couple of weeks, we're going to have a final understanding of exactly how long it's going to be. It was designed for 5 years with a hope that it would get to 10 years. However, they've done 2 burns already. They've used up a certain amount of fuel just to get it on its way. These were planned burns. And after the second burn, they came back, NASA came back and said, we did our math. I was on the meeting here. It was a very, very exciting meeting for me. We did the math. And we have enough fuel for, and this is the official NASA quote, significantly more than 10 years of life for the telescope, which is really exciting.
Wow.
They'll probably revise that and explain what significantly more means. I know what the numbers say, and it's a really, really good news if you are a person who's excited about more than 10 years of life on this incredible instrument and telescope. 5 years would have been such a bummer because it's $10 billion, and scientists have been working on this for 30 years. And significantly more than 10 years is like a really exciting thing for us scientists who want to use the telescope.
That is so cool. A follow-up question about its placement out there, coming in. What exactly is it orbiting? What kind of gravitational pull is it? Earth?
Yeah. So, golly, let's get into it, folks. Let's really get into Lagrange points, I guess. Lagrange gravity. Let's just do that. I want to find the gravity map. So again, I apologize if this is something that you're like, please don't talk about this. This is so tedious, but you asked the question, so we're answering it. So this is just the Wikipedia page for Lagrange points. And what you're seeing here is you're seeing a map where these lines, these circles, it's like a topographical map of gravity forces. And so, the sun is pulling gravity pretty hard. The gravity near the sun's pretty high. So that's what you're seeing here. So you can imagine that this is like a ball sitting on this point would want to fall downward this way, right? But a ball sitting here would either fall this way or this way. A ball sitting at L5 would fall down in every direction. That's unstable. You wouldn't want that. You wouldn't want a ball sitting at L5 because it would sit there. However, L2, this Lagrange point 2, it's actually stable in 2 ways. If you put a ball here, it's going to fall down in this direction towards the same point. Like imagine like a saddle point, right? Where in 2 directions, the ball would fall down there, but the ball actually, if it goes straight in either direction here, would be unstable. The thing is that this saddle point's exaggerated for this figure, but in actuality, it's pretty smooth. And what that means is you can put an object in orbit around this point here, and it will be, like imagine a ball kind of going around on the saddle point where you only have to kind of give it a little bit of push in certain spots, but it kind of will oscillate back and forth, up and down these hills as it goes around there, with just a little bit of extra force to kind of keep it from drifting a little too close to the Earth or a little too far away. Does that make sense?
I think so.
Yes.
It's complicated.
Yeah.
I get it.
Good. There you go. That's all I need to do.
Just,
Just
especially if you just imagine that there's a ball out there. Now this ball's invisible. It's just the center of gravity. It's not. There's not a planet or a
Like
moon
ball
or anything out there.
around in the air of some sort.
We're orbiting something like a point where everything is like falls towards it, and that's what the satellite, the telescope rather, is orbiting.
Yeah, it's just this green point here is the actual spot, but if you had a ball up on this hill, you would roll down this and then roll back and forth, right? If it rolled a little bit too far this way, it would go. But if it's very flat, like a very flat surface, it'll go. And there's whole YouTube videos with really smart physicists that are talking about this a little bit. But I just like to think about this. If there's anything that's just a word to describe me, smart is not the word to describe me. I'm just passionate. That's all you need to be, by the way. Then this thing will just kind of orbit around in this circle like that. And we do that because that allows us to not have to worry about the moon. Like if it was directly in a line of sight, then sometimes the moon would block the way, and that's not great. And having a big circle like this allows us also, and JWST will have a little bit of sway in a couple directions so that we can look at all sorts of stuff. Even though there are certain parts of the sky we'll only be able to look at some times of the year and vice versa.